Is my screen visible?
Yeah.
Yeah.
So I think we can start, right?
Yes, yes.
Okay.
आवाज नको करू फोनचा.
Karan, have you started broadcasting? Or... Hello?
Hello, Tarunam, are you there? Okay. So shall we start now or wait for some time?
Uh, yes, we can go ahead. Anuja. Yes.
All right. All right. Okay. Hello, everyone. A very good morning to all of you. Thank you so much for joining the webinar today. We are excited to have you here for our session on empowering healthcare with the BLE and React Native. In this session, we will explore how BLE is transforming healthcare by providing seamless connectivity, real time data transfer, and making the patient monitoring efficient. In this session, we'll walk you through how BLE enhance its integration with React Native, along with live demo on the integration of blood pressure monitoring device. We'll also cover the best practices for building the robust and reliable healthcare system. So let's get started.
Morning. I'm Maharata, and I have 6 years of experience in making mobile applications in React Native. And I have worked in several healthcare and lifestyle applications which focuses on building and providing robust solutions. So moving further, I would like to hand over to Rona for the further process. Over to you, Rona.
Thank you so much, guys, for your wonderful introduction. Hello, everyone. Good morning to all of you. My name is Ronak Kotak, and I'm having a 5+ years of experience in React Native. I am working as a senior software developer in my browser since 3+ years, and I have worked on many different kind of applications like social, dating, healthcare, real estate, etc. So let's start the webinar. This is our agenda for session today, and we are going to cover these below topics. So first we will see like what BLE is, then we will see key points for BLE and how it works, and compliance. After that, we will see use of BLE in healthcare along with one use case, and lastly, along with the use case, and we will end up with discussion and quiz. Next slide. Thank you. So first, let me what BLE is. So BLE, which is stand for Bluetooth Low Energy, is wireless between devices with lower power consumption. So unlike classic Bluetooth, BLE like monitors, smart watches, and it supports for real-time data transfer with lower power consumption. So it can we can make it crucial for remote health monitoring. So BLE is a part of Bluetooth 4.0, and smart or any IoT related device or tracking or location based services. So next, so here are key points about BLE. So there are like multiple key points like lower power consumption, short range, faster connection and deconnection for application compatibility, and addressing packets. So we will go through it one by one. So for lower power consumption, like as I mentioned in previous, BLE is very energy efficient. It consumes like lower power as compared to the classic Bluetooth, and operate for a longer time of period without frequent charging. Second is short range. So BLE typically operates over 10 to 100 200 meters of range, depending on like based on OS or like industry standards or any other regulations. Connection speed connection. So BLE like for the perfect scenario where data needs to transfer intermediately or in a fast way. Fourth is application. So BLE is used in various kind of application like fitness devices or tracking or location based devices and services. Fifth is compatible. BLE is backward compatible with market. And last is advertising packets. BLE device discover each other by periodically broadcasting the data, which we can call as like advertising packets. Uh, they contain the info about BLE's device. And yes, this was the key points. Next, okay. So now we will go for like how BLE works. Okay. So BLE communication is based on client and server model. where a device is like one is idea using in a two ways, like first with like this comparison table and second with the communication flow. So point is power consumption. Typically low power devices, while central are typically high powered energy devices. So after connection is established, like peripheral device act as a slave, while central device act as a host or master. And the last point is like example, like smartwatch, mobile phone, smartphone, they are part of central devices. So our next agenda is BLE communication workflow. So as I mentioned previously, using the packets, and in opposite side on, we can check for the Bluetooth permission based on OS or depending on OS and other standards. It's nearby connected BLE devices or peripheral devices with our application. So if list of devices are available, we can go from the external operation. After like connection is established, we can find and discover the list of services for that device. And if we get the list of services, we get we have to get particular service in that in next further section we want to perform the action. So if that service is found, we can go to find list of services which are associated with that single service. If list of services characteristics found, we can find for particular single characteristic in which we want to perform the action or operation. Left, right, notify or indicate operation. For this BLE operation, we can get idea in upcoming section. So this was the communication flow, and our next agenda is allows central device like mobile to retrieve the value from peripheral devices value or such as like battery level indicator or battery percentage or device status. So for an example, like mobile app reads latest blood pressure measurement from BL enabled blood pressure monitor.
we develop any medical application that is integrated with the medical device, the compliance with the FDA plays the crucial role. And that is why the Apple and Google also provide certain safety and security guidelines for the developer to achieve the same. All right, next slide. Yes. So now we'll see what exactly we need to know about the FDA compliance. So basically, FDA review process includes the pre-market review process, post-market monitoring, and other regulatory activities which are essential to ensure the safety, effectiveness, and quality of medical product throughout their life cycle. So these are few review process which takes place during their life cycle. First is the pre-market review process. Before launching any application in the US market, the medical app may need the FDA approval depending on their risk level. So first is the class 1, which is considered as a low risk application. Generally, it does not need the FDA review. Class 2 and get the FDA clearance or the approval before release. In addition to assessing the risk level, developer must determine that whether application qualified as a medical device. This depends on whether it meets certain criterias like if the application is designed to diagnose and treat the medical conditions or impacting certain function of human body, or any clinical decision support for the healthcare professional. So by assessing this criteria and the risk level, we can identify that the FDA approval for the application is needed or not. If we take an example of this, could be if the application only displays the ECG data, then the medical device related in the application needs the FDA clearance. If the application provides certain information providing certain options. So yeah, that was about the pre-market review process. Next is the post-market monitoring. So even after approval of the application, companies must keep the track of the performance and report any safety issues or diverse event to the FDA. This process helps in catching the unexpected risks that were not found during the testing. Then next we have the other important regulations, which includes the GDPR and HIPAA regulations that application must follow. So it is actually an important regulation while building any healthcare application, that it must comply with the HIPAA and GDPR standard to ensure secure handling and the protection of the health data. So these are the review processes that any health or medical application go through throughout their life cycle. And by following these compliances, developer can build the reliable, secure healthcare solution that positively impact the patient and complies with the FDA compliances. So moving ahead, on the next slide we'll see uh, the role of BLE in the healthcare applications and the industry. So here I have mentioned few applications. One of the most popular application of BLE in the healthcare is the remote patient monitoring, where the patient connects the BLE enabled medical device to the application and allows the doctors to remotely monitor their health. And this is especially useful for the chronic disease management like diabetes, hypertension, cardiac care, which actually reduces the need for the patient to for the frequent hospital visits. Next application is the patient monitoring in the wearable devices. The example of this application could be the smart watches, ECG monitor, and glucose tracker that uses that basically uses the BLE to track the vital signs and sync the data with the mobile app for the continuous health monitoring. Next application is the healthcare and fitness. In this, BLE enables the fitness tracker and health gadgets to monitor the day-to-day activities like the calories, sleep, workout, which promotes the healthier lifestyle. BLE is also used in the clinical trials and research for collecting the real-time health data, tracking medication, and predicting the future health outcomes. As well, where the BLE has been widely used. So moving ahead, um, so now let me give you an overview of our use case that we have developed. that is the remote patient monitoring application. We have built the patient facing mobile application that can be connected to the blood pressure monitoring device named as a Viatom BP2A. So the application is responsible to collect and display the blood pressure readings, and the assigned care manager and the physician can monitor the patient health remotely. So this application we have developed in the React Native, and the SDK used for the BLE integration is React Native BLE Manager. Okay, so now we'll walk you through the challenges and the learnings which we had while implementing the BLE device into the application. First, we'll see the challenges which we have faced and the solutions which we have implemented for the same. So first challenge was the data streaming issue. Here, the main problem was after establishing the connection between the central and peripheral, the integrated BLE device does not automatically start sending the data when the notification is enabled for particular characteristics. So the reason was because some devices like notification of the heart rate monitor, it starts sending data automatically. But this does not happen with the blood pressure monitoring device. The reason is the certain sensors, like the blood pressure monitor sensors, follows a request response model, which requires the explicit write command to initiate and maintain the continuous data streaming. So the solution which we have implemented for this is, in addition to enabling notification, apps send the periodic write command at certain time interval once the connection is established. So the write command which we have implemented here is the write with response. So that again earlier explained by the Ronak. By doing this, the app starts receiving the notification as expected, and continuous data streaming can be achieved. So this is how we have fixed the data streaming issue. Next slide. Now we'll see the next challenge which we have faced. So there was the packet size limitation issue. So main problem here was the BLE device initially set to transmit the data of 23-byte packet format. So which was creating the challenge when processing the larger data set such as vital signs and multiple health metrics. So as a result, BLE as a MTU started transmitted in the form of packet, and MTU defines the maximum data size that can be transmitted in the single data packet. So MTU has default size of 23 byte, but that can be increased up to 512 byte depending on the device and the OS. So in order to overcome this bottleneck, we have increased the MTU size up to 512 byte. So again, the SDK which we have used provides certain methods to handle this.
data what it is explicitly asked for. Because BLE devices don't send data on their own. For that purpose only, the central device has to specify. Second, here comes point comes here is reliability. Because every piece of data is linked to that specific command, it is easier to monitor success and failures. If the command fails, we know exactly which operation needs to retry. Third one comes is scalability. And by adding new commands like extra health metrics or any for the future purposes, it doesn't require an entire overhaul of the system. Because the structured design may try to explain you by taking a real world example, we can consider it like we are a patient and we are monitoring the heart rate. So from the central device, we send a command called as start heart rate measurement once the device is connected. And the device means the BP measuring device then to stop heart rate measurement to tell the device that it should not send the further data, thus preserving battery on both ends. So overall, a command-based approach keeps the data flow organized, prevents miscommunication, and ensures that healthcare app reliably sends the data without any confusion or any further delays. So this was all about command-based communication. Moving further is handling connection instability. If I try to give a summarize into a example, in our day-to-day life, whatever the wireless communication that we interact with, whether it's Bluetooth or Wi-Fi, any kind, so wireless connection may drop for certain reasons. It can lose the power or went out of similar case happens through a Bluetooth device. It can also lose power or went out of range and it disconnects after that. So what happens is after coming into our central blood pressure monitoring device, they failed to reconnect. And this was due to device losing its previous state. And this started connection from scratch, which caused delays and which ultimately leads to the user frustration. So for this, we have implemented a solution. We have built a reconnection system that immediately tries to reconnect with the BLE device as soon as it is detected. And for that, we have used the method that is provided by the library which we have used. Here in this case, React Native BLE Manager, Restore Identifier Key for iOS, and Force Legacy for Android. So what it does exactly is in iOS, this restore identifier key leverages the restoration feature. Essentially, what we do is we provide a string to this restore identifier key, which tells the iOS system to remember that the BLE peripheral was connected and this is its necessary information. Means the restore identifier key stores the information of that particular BLE device so that it will be used in the further case. Even if the app is closed or phone or power, even in that case, it stores the information of which peripheral device that it previously. It hands back this necessary context or information, and whenever if the BLE device tries to connect with the it connects Android, we use Force Legacy. So what force legacy does is it uses older start instead of using newer APIs like start scan for BLE integration. So by setting force legacy to true, this library can, which may be supported on older devices, uh, which are reliable in certain environments, and uh, it also caters the hardware and compatibility issues in Android. And because BLE device communicate at fixed intervals to save the power, there is an inherent delay while reconnecting. In the technical terminology, we call this as latency. Uh, when our Bluetooth device takes a lot of time to connect, we call this as latency. Read request command to the peripheral device, and peripheral device then processes that request and sends the data back to the smartphone or central device in this case. So here you can see this A5F303. This is actually the command that we are sending to the peripheral device. And in order, we get the information like device name, manufacturing info, or any battery percentage. So this was the read operation. Now on the right side, there is the write operation. So there are two types of write operation. That is a write with response and write without response. In this case, in our project, we have used write with response command because we want the peripheral data to send us the data back if any data is available. So for that, from the central device, we send the command to the peripheral device on the certain characteristics, and the peripheral device then processes the command and sends us back the information to the central device. So here in this case, we have sent the right command to get the live blood pressure reading from the peripheral device, and peripheral device in this case sends us the latest data which we have asked for. So this was a read and write operation. Moving further, there is the notify operation. So previously, on the previous slide, Anuja have told us that certain BLE devices don't stream data on their own. Means, for example, when we scan and after that connect, and after that we enable the notification. Means, whenever there is a new data, we should notify. Means central device should be notified, but peripheral device, in this case blood pressure monitor, don't send data on their own. because there are some sensors issues like they are designed to be like that to consume the low power. So in this notify operation, firstly we subscribe to that specific characteristics from which we should get the real-time reading, and after that we send the command at a specific interval continuously to the peripheral device in order to get the latest data. As you can see in this illustration, in the second column, we are sending a command and peripheral device is sending us back with the updated value for that characteristics. Like here in this pressure is 10 and the status is in measurement. Similarly, we again send the command and it again responds us back. And after that, when the reading is totally completed, we get the final reading, that is historic, diastolic, and the status measurement is completed. So here is how command-based communication works uh, in the read, write, and notify operations. So further moving on, we will see the live demonstration of how the BLE device scans, connects, and how it actually processes the data. So for that, I will share my screen. Just a minute. Hello, attendees. Can you confirm that is my phone screen visible or not?
Yes, okay.
Okay, thank you for that. So this is our first screen where we will just scan and connect with the blood pressure device. So for that, just let me give you overview. So this is the mm, blood pressure device which will be using. Uh, it is used to measure the heart rate, systolic, diastolic, and blood pressure. It's used for generally remotely monitoring the patients. So firstly, we need to ensure that we give all the necessary permissions like location and to that this app can scan and connect to the specific Bluetooth devices. And after that, we need to ensure that our phone's Bluetooth is also on. So for that, let us see how it gets connected. Let me create my camera. So is this visible? My device and phone. Firstly, we will turn on our Bluetooth device like this, and after that, we will just press scan Bluetooth button in our smartphone, and it will just scan. So as you can see in this screen, that we have scanned this device, and now we have successfully connected with this device also.
Arta, can you just zoom for that device? Readings are not properly visible. Little bit.
Yes. For let me wear this device into and
Okay.
let the device. Okay, so is my device visible properly? Okay. So here in our phone screen, you can see the peripheral detail screen where there are name, ID, RSS, advertising, and the local issues which we have write the which we have used the right operation to get all this information from that specific device. And this Bluetooth device offers certain services and characteristics for that. Like first one is service 1800, second one is FE59, and third one is Atlas. This we will use this third one because the manufacturer have told us that this characteristics will be used to notify the instruction at live. So we will take the live reading now. So here it is. So as you can see in the screen, if I press the take reading button, it will send the command to the BLE device to start heart rate measurement. Yes. As here you can see, the pressure and the real-time reading has been transferred to the phone in real time. So now we can see here the reading is completed and the completed measurement reading has been shown in our phone. So this was how the live reading takes place, and this is how entire operations we can perform. So here you have seen how the so here you saw how smartphone can easily connect to a medical device to keep a track of important health sign for elderly patients or whoever who are patients that they want to track their vital signs. And due to this simple connection, means the vital health information is gathered quickly and shared accurately. And this makes very easier for both patient and doctors to stay informed in healthcare industry. And this kind of technology is transforming how the care is delivered. From the remote monitoring to chronic conditions like diabetes or heart rate. And with this technology that is accessible to anyone or anywhere they are, it
Hello, Artha. Anuja, am I audible?
Yes, you are audible. I think there is some issue with his end. Let me check.
Okay, yes. Sorry, guys. Let's wait for Artha to stable like his.
audible to you.
Yeah, you're audible now.
Yes, Artha. Like, can you repeat your last maybe 1 or 2 minute sentences, please? Because your
Okay.
internet was not working properly. So.
So, so as we saw in the live demo that how a smartphone can be easily connected with the medical device to keep track of important health signs. And this simple connection means the vital health information is gathered quickly and shared accurately. And this makes easier for both patient and as well as doctor to stay informed. And in the healthcare industry, this kind of technology is transforming how the care is delivered at last. So, from remote patient monitoring to chronic conditions like diabetes and heart rate disease. And with this technology, it is accessible to anyone and everyone and wherever they are. So this is very good technology for that. So moving on to further,
Artha, can you share your slide, please?
yes. So we have saw just saw the live demo for it. So guys, do you have any questions? You can just drop in the chat section. Okay, so we will continue now. So thank you for everyone who attended this informative session on empowering healthcare with BLE in React Native. Hope you guys enjoyed it. Thank you.
Aharta,
Yes.
a quiz section is remaining.
Okay, so just a minute. Yes. So it's my slide is visible. We have organized a quiz for you guys where you will have 4 minutes to solve. And for that, we will you have to register everything first name and last name. And winner will be just decided on the basis of your score. So let me just drop the quiz link in chat section. So as the timer will start, the link will be valid, and after 4 minutes, it will be invalid. Okay, so I'm starting the timer now.
Artha, just 1 minute. Let me copy paste the quiz URL in Q&A section. Just give a second. Okay. Hello guys. I have shared the quiz link in a Q&A section, so you can fill up your first name, last name, name, letter, ICD, and you can go for like quiz. Artha, you can start the timer.
Okay.
So is there any problem?
Yes, some problem.
Okay. Artha, I have shared one link. Can you in chat section? Can you open it and play accordingly?
Okay, third time I have just begun.
Yes.
Okay, so the tallying are finished. So thank you for those who have completed the quiz. Now, there are this current job openings in company where we have no instant developer and this much requirements. And once the winner will get announced, you will be get notified over an email or in the LinkedIn page. Those who have completed. And thank you for everyone and for your time and have a good day. Thank you.